to this point, we've looked at integrals. We've established that we can sometimes need to find the value of c. Yes? That's where we get given extra information. But now what we're going to be looking at is what we call definite integrals. Okay, so what this is where you actually have a numerical value assigned to the integral. That's what all those words mean. How do you know when you're finding a definite integral? Well, you will notice that in the question they will have these two values here in addition to the normal integral sine and dx. Okay? So if you see these two values or values top and bottom, it means that you are finding a definite integral. That means that your answer is going to be a number, not a letter. Okay? These numbers here are called limits of integration. Okay, so what we're going to do is we're going to follow these steps. We're going to find the indefinite integrals, so that's what we've been finding up to now. We're not going to bother adding c to it. The reason being is that to find the definite integral, we find the integral with this value substituted, and we subtract the integral with this value substituted. So obviously, if they both have a c, then that c is going to disappear when you subtract them. So there's no need to worry about c. So omit means leave out. So we draw square brackets, hang the limits on the end. We then stick the values of x in, the top and bottom, and subtract and evaluate. So let's go ahead and oh my gosh. Alright, so integral of 3x squared plus 2, Sarah Glanwyn.
3x. 3x.
Wait. Oh, no, it's a...
We're gonna look at an area. We're gonna watch it during an exam. Okay.
Yeah, okay, go Sarah.
3x cubed over 3 plus 2 squared. Just kidding. 2x over plus.
Okay, so this is what we don't have to worry about the c because we're going to end up subtracting. Okay? But you're not going to leave next to it. Alright, so we've written square brackets. We then literally just write, it's called hang the limits. I don't know why we didn't say that. But you write these limits at the right hand side. Okay? Now, at this point, we should be looking at this expression going, hold your horses. We've got 3 on the top and the bottom, so that's about the way you can go. So we've got x cubed plus 2x, and then we've got limits of 1 and negative 2. Okay?
I don't want to say I didn't realize that you were repeating.
Alright, so we're now going to substitute the value of 1 in there, so we're going to have 1 cubed plus 2 lots of 1. Okay, that's going to be one of my usual what's this. And then I'm going to subtract negative 2 cubed plus 2 lots of negative 2.
Are you minusing it because it's negative 2?
No, so you will always subtract. Okay, so you'll have the first value substituted in, subtract the second value substituted. In a second I'm going to explain why we do this. Okay, but for now let's just learn the process. So 1 cubed is 1 plus 2 lots of 1, which is 2. So our value there is obviously going to be 3. And then negative 2 cubed is negative 8, as again, plus 2 lots of negative 2. 2 lots of negative 2 is okay, so we've got negative 8 take away 4. What's negative 8 take away 4?
Negative 12.
So we've now got 3 subtract negative 12.
So it's going to be 13.
Yeah, excellent, because obviously our take away negative ends up adding it. So our value is 15. Awesome. I think
That is yeah, like the definite ones are gonna be indefinite.
above it.
I could send emails. Wait, which one is it?
See you on the board there.
That?
She now has that
Yeah, just
recorded.
click that.
Which one? This?
Alright, so you may want to say that because I might pause in a minute. Because nothing's right just yet. So the method for evaluating the definite integral is find the indefinite integral, omit C, draw square brackets, replace the values with the top limit and the bottom limit, subtract the bracket. So that's what we do for each one of them. There. Let's go.
I gotta write.
Jennifer.
Sarah, you need to finish the microphone. Microphone's off the computer.
So we're gonna do for the give me a second. No, x 3 over 3
Nice.
minus minus
Oh,
minus 7 minus 7 and then
no, keep going. 7.
x squared. And that's it.
Okay.
Over 2
That's not it.
plus c plus 12. That's the 12 here. Okay. Oh,
Okay, so, and I know it is really challenging. If you remember, I did say it's really tricky as a teacher to decide, do we separate the teaching, the differentiation and integration, or do we join it together? I'm going with joining it together to try and help keep it in the same track of it, but it does mean that it can be confusing remembering which one you're doing. So integration, remember the powers are increasing, okay? For differentiation, that's when the powers decrease. All right, so I'm going to hang my limit.
1 over 1. There you go.
I feel like I can't talk. I still did.
All right, so then we're going to substitute our values in. So we've got 1 cubed. Oh, we should have said that thing. 1 cubed over 3. Subtract 7 lots of 1 squared over 2 plus 12 lots of 1. And then we're subtracting negative 1 cubed over 3.
This is a long
7 lots of negative 1 squared over 2 plus 12 lots of negative 1. Okay? Now obviously this kind of question could well be on a non-cap paper. So you have to be able to do this without a calculator. So 1 cubed over 3 is going to be 1/3. Yeah?
Yeah. Oh, yeah.
So then we've got 1 squared, which is 1 multiplied by 7. So we've got minus 7 over 2 plus 12. Negative 1 cubed is negative 1. Okay, so that's negative 1/3. Negative 1 squared is 1, so we're doing take away 7 over 2. And then we've got to take away 12. Please. Okay? Now, rather than work out what each bracket is, no, it won't end up with that. We want to recognize, especially in this situation, we've got some similar numbers here. We've got negative 7 over 2, and we are subtracting negative 7 over 2.
So that cancels out.
So actually what we can do is we can just cross those two out. Yes, you're happy with that? Then we're going to try and work this together. We've got 1/3 subtract negative 1/3. So that means we're going to add it.
2
Yes?
6
So that's going to be 2
thirds.
So we've done that and that. And then we've got 12 subtract negative 12. So we end up adding it. So we've got plus 24. Yeah, you happy with that?
Yeah.
And so we can leave this as a mixed number, 24 and 2/3. So if you've got 2/3 plus 24, it's going to be 24 and 2/3.
I remember mixed numbers.
so there's that one done. Okay? Easy. You guys have a go at the next one for me. Could you call me Sarah, please?
I got you.
I got you.
Hi, Miss Harrison. We love you.
Alright, okay, so these are the examples. I think we did 2 already.
Yeah.
And then, so this one is example 3, kindly done by Jennifer. And then this
Hi,
one
Shelby.
is number 4, also done by Jennifer. And
Yeah, mine.
And then this one, number 5. So number 5 would actually, so just note for number 5, remember we've got root y, so that has to be rewritten as y, so how half will start. These are y's and not x's, but same process, even though it's a y. And once we've got this in account, we would then, once we've got to this point, or even before, you would try getting the calculator. Does anyone have the natural answer? No, it did. Alright, but, so this is probably a good place to actually show you how the calculator does do all of this for you. Okay? It even, so it means that you don't even have to work out this part. It is. If you get given a question like this, you can just enter that expression, that exact thing, press enter, and your calculator works out what the definition for you is. So, let me show you that process. I'll ask you to back. So can you have your caps out when you've got whatever we can, so you know which buttons to press?
You're so lovely, Miss Harrison. Like, I just love you so much and adore you.
Why are you saying that? You're making me nervous.
That's her calculator.
Okay, now, so as I've said, the calculator actually does all this for you. So in an exam, if you had something like this, it's doable to actually show the steps like this. Yes, we can write y to the half, we can then integrate that. However, there could be situations where they give you an expression here that's totally crazy. All right, and you might look at it and go, she's never taught us how to integrate that. How on earth are we supposed to do that? But if it's on paper 2, you will be expected to use the calculator. It won't be worth many marks, and because you are expected to just literally type it into the calculator. All right, how do we do that? Jushna, chill out. So, we press math. This button here, I know. And 9. And you should get a screen that looks like that.
Yeah.
All right, so let's put stuff in. So let's do one of the examples we did where we knew the answer. Yes, that's totes what I was going to say, Jennifer. You and I are on the same page. All right, so we're going to type 2 at the top, negative 2 at the bottom. Make sure you're using negative, not subtract. Oops. Then we've got 6 x. Remember, x is this button up here. The x, comma t. This one, the red one, it's highlighted here. 6x squared minus 2x minus 3 minus 2x minus 3. And Olivia tells us it's right.
Yeah.
And then make sure you put the letter X in there and then press enter. And funnily enough, we got 20, which is what we got. We are over awesome.
Oh, Miss Harrison.